in English. Okay, so now, so I've got my ball. 89 was my number, so this is my autograph. It didn't get cool until I was done, and no one wants it anymore. Huh? College football number. My high school football number was 15, and it was black and gold. Anyway. You want me to not talk more about that, like how we kicked the crap out of Kemper when I played? Well, Trojan, baby. The Trojan. All right, so anyway, Isaac might get a play down on their field next year. You never know. Which apparently is new, and I'm not going to like it because it's not the old bowl.
Yeah, it's nice.
It is new.
It's not the Trojan Bowl anymore?
It's the same place, but they put that turf.
They got the scoreboard.
Turf, Trojan man. Look at that. I left that up yesterday. Look how good it is. I left it up on purpose just to make sure it still came off. I probably shouldn't have. It came off right away yesterday. All right, what questions you got in 2.5? So 2.5 theoretically is due today. So I know I said it's separate, but since you're done, we can do it. Hannah, you're not going to be able to see me the whole time. I'm not going to move that around. But I do want to know what you got. Hannah, we're gonna put on you first. Oh, there's only 2 problems, right? So what did you get for? When does it reverse direction in number 10?
Like when it's like the positive or negative thingy, like that.
T equals 2, but negative 12.
Yeah, how many seconds? Yeah, like the time. 2 seconds. 2 seconds, okay? So I agree with that. If you got that, you did your chart. Did you do the acceleration chart on number 10? So, huh?
Not the acceleration.
You didn't?
Why did the chart?
Didn't I put in the notes to chart velocity and acceleration? I did. It's on. So if you haven't done that, do that for tomorrow. I'll do one like that again and just talk about that again. And then number 20, what did you get? When does it stop? Did you do number? You got number 20 now?
Like completely stop. Wait a second. Or like stop in here 1 second.
First stop's at 1 second, right?
And then stop.
All right. And then what'd you get for velocity? What'd you get for speed? Part E.
8 feet per second.
8 feet per second. That sounds pretty good. F, what'd you get there? Velocity at 2 seconds.
0.
Or the speed at 2 seconds. No.
32 feet per second.
Okay. That sounds better. And then, so 2.6, so we got some word problem stuff in 2.6. So do you want a velocity and acceleration chart on something? I can see if I can do it. Did we have one? So by the way, I do want to clarify in the book, so the question was on WhatsApp, like, hey, I thought you said you can't have negative time. Correct, you can't have negative time, but if we said 2020 is time 0, we could go back to 1987 when I was playing against Kemper in 1988, right? We could go back, that'd be negative time. So you can, if you just have a function, that's why the book has negative values for t. But if it's a real life problem, you're okay in my book saying t has to be greater than or equal to 0. Okay? But if they just have a function, they're going to have plus and minuses. They're going to allow t to be negative. You don't have to do that. So when I say the book is wrong, I got to be a bit careful because if it's not specifically time that they're talking about, right? Or depending on how they define their time. But if time is in seconds, we're not going to talk about negative seconds. We're not going to do that. So I'm okay with you saying t is greater than or equal to 0. And you can hold that against me if for some reason I hold that against you, if you did that. I'd probably count off for negative time because of that's what I said. And then what else? What was I gonna say? Anything else on that? Let's do an acceleration one. Is there like an odd in there in 2.5 that I can do a chart for acceleration? So I just want to do one real quick. They have examples in the book, but did we do number 9?
Yeah,
Did I do the acceleration for number 9? No, I don't think I did. Did I? Okay, so let's do number 9. Can somebody read that to me?
S equals t cubed plus 3t squared minus 9t plus 4.
Okay, Hannah, can you see that okay? Okay, so anyway, so we've got that. So basically we want the velocity, right? The velocity at time t is s prime. We already did this one. But anyway, so it's 3t squared plus 6t minus 9, right? That's what that is. And then we factor that, we set that equal to 0 and basically factored a 3 out, right? So it's 3 times t squared plus 2t minus 3 equals 0. And then we said that, so we factored that or canceled the 3 out on both sides. And we had t plus 3 times t minus 1 equals 0, right? We did this? These are critical. So the critical numbers, t equals -3, which can't happen, or, so t equals -3 can't happen, or t equals 1 second. That's a critical number. What does that mean? That's where we want to split our chart up, right? So we want that splitting it up, and the velocity is 0 at that point, means it stops, right? That's a stop point. We need to stop and turn around or stop and keep going. Correct? Okay, so we need that. That's what's called a critical number. So we're going to split our chart. But we also have critical numbers where the acceleration is 0, or technically we'll find out later, it could be where it's undefined. But if it's undefined, we're not going to be moving around, right? So we're not going to use the undefined points, but we're going to need acceleration to be 0. So what is the acceleration? Well, the acceleration is v prime at t, or s double prime at t, right? It's the derivative of the derivative. So the derivative is 3t squared minus, or plus 6t minus 9. Derivative of that is what? 6t plus 6. Everybody agree? So you need to be able to do those derivative terms in your head very quickly. So if you're not good, I can give you con if you want. You want more con on this stuff? You don't want con? John wants con. John's got a great attitude. Anyway, make sure you're really good at taking derivatives of functions that are not overly complicated. Know those derivative rules. But anyway, we're going to set that equal to 0. So when the acceleration is 0, what's happening? What's the concept? No pull. So there's no pull if the acceleration is 0. Okay? If the acceleration is positive, what does that mean? Which way is it pulling? To the right. Normally, we're going to have the right be positive. And if its acceleration is negative, it's pulling to the left. Correct? Okay. Based on direction. So anyway, we have another. This one, I don't like this one at all. It doesn't give another point. Then does it give t equals 1? Negative 1. I hate this example.
We could do 11.
Huh?
We could do number 11.
Okay. Let's do that. So this says, you know, t equals 6 times quantity t plus 1 equals 0, so t equals minus 1. Well, that can't happen either. So that doesn't give us a new chart. What's the one for number? Was I doing? Did I finish the chart yesterday on the one I was doing? Was that, which one did I do? Was it 11? No.
You did like s equals 1/3t minus 5t squared.
Did I finish it?
The chart.
Yeah.
We didn't have acceleration yet. I don't think.
Okay. That's all right. Let's do 11. Let's do 11 quick. What's S? Sorry.
2/3 t cubed plus 3 halves squared.
T squared.
Yeah, t squared minus 2t plus 4.
plus 4?
Yep.
Okay, so S prime is the velocity, right? So the velocity is ds dt. The derivative of this is what? First
T squared plus 3t minus 2.
Okay, and then we're going to find critical numbers is where this is 0 or undefined, where it's polynomial is defined everywhere, right? So it's where it's 0. So how do we factor this sucker? So 2t squared is 2t and t, right? And then what I got to multiply, and 2 is 1 and 2. So if I multiply the 2 times 2 for the outer and inner, that's 4. And I need that to be positive, so this one's going to be negative. Right? That works? So this equals 0. So what's t equal? This one equals 0, or this one equals 0. So 2t equals 1, t equals a half, right? And if it's seconds or whatever, what's this one? T equals minus 2. Can't happen, right? Okay, so 1/2 is going to split up the as far as velocity. So the velocity is 0 at t equals a half, which means what when the velocity is 0, Jordan? Velocity is 0. It's stopped. The particle is stopped, right? So now let's do the acceleration. And so that's v prime dv dt, or s double prime, right? So what's that? What is it? 4t. Oh crap, why you give me these? Oh. Why is that one? 4t what?
Plus 3.
I don't like it. So here's what I'm going to do. I'm going to change the problem. You ready? So this is called example. And this is going to be a minus. That's going to be a minus. Okay, everybody good? So the derivative is minus 3t. Now what? This is plus 1 minus 2. Everybody good with that? And this is minus a half, which we don't like. And this is t equals 2. So this is just an example. It's not this one. And then the acceleration now is going to be 4t minus 3, right? We good with this? Okay. Set that equal to 0. So 4t equals 3. T equals 3/4. So I have another critical, and we're going to assume this is seconds. So this is my example. It's in seconds. So anyway, so we have a chart that's going to be split up with t equals 3/4 and t equals 2. Everybody good with that? So the only thing I did is change number 11 and put minus sign on the second term. That's the only difference here. But since we're eliminating the negative time, this is going to be better for our chart. And then I'm going to graph it. Okay, so I'm going to, do you need this up there? You good? Erase it now. What's this? How cool is that? I know, awesome. Anyway, so here's my, what do I need? I need my interval, right? Now, and once again, I don't care if you're doing brackets and parentheses or what, but anyway, 0 is less or equal to t is less than what? What was the one first critical number? 3/4. And then we're going to have t equals 3/4. And then we have 3/4 is strictly less than t is strictly less than, what do I go up to? 2. And then t equals 2, we need to know it's there, and then t is greater than 2. Right? So, and then I have my test t there. So what's an easy number in between 0 and 3/4? Half. And then we got 3/4, we have to use that. Easy number in between here, strictly in between. 1 is the only easy number in there. And then we have 2, and then maybe I'll go 3. Okay, and then I need the sign of what? Sign of the velocity. And I also need the sign of the acceleration. So it's really d of t, right? And sign of a of t. And if right is the positive direction, if the velocity is positive, which way are we moving, Luke? Which way is the particle moving if the velocity is positive? Moving to the right. And Jack, if the velocity is negative, moving left. So our conclusion for our particle is right here. So anyway, sine of B and T. By the way, let me go back and see what B was. What was B? It was 2t squared. And then we factored in, it was 2t, and there was a 2 there, and that was a -2 and a +1. Okay, so instead of plugging it into the velocity equation, I can plug it into the factor form, because I don't care what the actual answer is, I just care if it's positive or negative, right? So I'm trying to show you some math tricks. You do this with pretty much everybody that doesn't have me as a teacher. But anyway, you get this from me. So if I plug in a half here, is this side positive, the first factor positive or negative? Positive times negative is negative. So what did I do? I'm moving left. The particle's moving left, correct? And if I plug in 3/4, what do you get?
Negative.
Positive times negative, which is negative. So it's moving left. Do you remember that 3/4 came from when the acceleration was 0, so the velocity is not going to change potentially until it stops. And it may not change after that because it could stop and keep going left, right? But we got to find out. Anyway, if I plug in 1, positive times negative, which is negative, so I'm still moving left, so that's expected. But when the velocity is 0, which happens in 2 seconds, my particle is stopped. So I need to know if it's going to stop and turn around, or if it's going to stop and keep going. So I got to plug in 3. If I plug in 3, what do we get? Positive times positive, which is positive, which means I move right. So now that stop, and I put a TA after that, that's stop and turn around. And this is going to help me chart it. Everybody agree that that's the velocity chart. So if it only asks for velocity, I wouldn't even have needed that 3/4 in there if it came from when the acceleration was 0. I'll use a different color here and see if this works. Anyway, I'll use blue. But at 3/4, the acceleration is, what was that? What was that one? The acceleration.
4t minus 3.
Blue doesn't like to work very good. Anyway, so plugging in, if I plug in 3/4, the acceleration is 0. Okay, blue doesn't work. We're using purple. Purple and gold for Panthers. I need a gold color. Anyway, but this is 0, which says what? No pole, right? And then what about if I plug in a half to this? That's 2 minus 3, which is negative, right? So what does that mean? Left pole. Okay, well, it's left pole, but that's not really what I need. That's not really what I need to put in there. I don't need to put in left pole. We know it's left pole because it's negative. But what's the particle doing? If I'm moving left and I have left pole, then the particle is speeding up. Correct? Because you're pulling in the same direction. So what I really want there, it is left pole. I'm okay if you put left pole, but I do want to have you to have it speeding up. That makes sense? Okay. And then here I'm moving left, but I don't have any pole. Okay. So think about it, if you're in outer space and it's a rocket ship and it uses the gas, to get going toward the moon, and then it shuts the gas off and it's still moving, but there's no pull on it, right? Because there's no gravity out there, but it's still moving that direction, right? Okay. Anyway, I actually met an astronaut that's been on the other side of the moon.
Neil.
No, it wasn't Neil. He came to Carroll. This was only like 2 years ago. Anyway, no, it wasn't. But it wasn't. He was on like some of the early Apollos. I think 75 might have been one that he was on. Like, I don't know. anyway, but that was cool to hear his story. But you know what was sad? So he was on the other side of the moon where then you can see out everything. And I was like, so I asked him about his faith. I'm like, so did that make you closer to God being out there? He said no. And I thought that was so sad. Like, so you're out there and you can see like creation at a level that we can't see here. And you think that's just a fluke? I don't know, how sad.
What is his faith? What religion he belongs
He doesn't have one now.
to?
But you know what's interesting? He will, because he's like, he was 80 something. He will, or he's going to wish he had one, right? Like here, I don't know when, could have been last year. Right? These are, yeah, I you know, it was interesting, but it was also sad. And I've talked to all kinds of mathematicians and scientists and everything else. And there are some that they think, oh, I'm so smart and you can figure everything out and there's reasons for this and that. Right, but who made those reasons? And I've had so much math, like you guys all did pre-calc so you could do some of the calc stuff that we're doing, getting into finally, right? But my goodness, I've done so much math that like it's all connected. It is incredible how connected that is. It's not just a fluke, guys. You're not a fluke. You're an important person, and I will care about you after you do well in my class. So anyway, no pressure. You're done. All right, but anyway, that guy's a Husker fan. I think you're done, guy. But anyway, what about this? If I plug in 1 into here, I got 4 minus 3, which is what? Positive. So I have right pole, but I'm moving. So what's the particle doing? It's slowing down. Slow down or slowing down there, right? And then what if I plug in 2 to that? I still get positive, right? My accelerator, so I have right pole. I'm stopped, but I'm pulling right. So I still have right pole. So here I do put the right pole, because even though I'm stopped, think about it, if somebody's pulling against me, which way was I moving? Left. So I'm going this way. But that rubber band's getting real tight, and it just catches me, and I just stop before it starts pulling me back, right? Or I can break the rubber band and run through. But anyway, so what happens here next? You plug in a 3, we get a positive, so I'm moving right, and I have right pole. So what does that mean? I'm speeding up. Some speed up. Okay, so that's what's going on with my particle, and then what I can do is I can utilize that to graph that thing, right? So I'm going to graph this above, and then this is, I'll erase this because I don't need that anymore. I just needed that for the critical numbers. But anyway, if I graph this thing on the s-axis, so here's my position, at time 0, where are you at? When t equals 0, it's 4, right? So I'm over at 4 when t equals 0. So I can even label this here, but at t equals 0 seconds, I'm to the right 4 units. That's my position. And then I need to know where I'm at critical times. Well, at 2 seconds, so basically where am I going? I'm moving left, so I start out going left, and then at 2 seconds I stop, and I actually turn around. So I plug in 2 to this, what do you get? It'll help here. So 8, 2/3 of 8, 16/3, minus what? 6? Huh? I don't know. 12 is 12 halves, right? Am I doing it? So 6, so what did I say? 16/3 minus 6. And then what? Minus 4, that minus 10. Plus 4 is minus 6, so 16/3 minus 6. Is that right? Did I do that right? I don't know. What's 16/3 minus? I don't know. It's 18/3. Negative 2/3. Is that right? There's t equals 0. And if I go to negative 2/3, it'd be right here. So I'm moving left. So I hit this spot at negative 2/3, and then stop and turn around and go back to the right. So it's a simple one-stop shop, but you might have a couple of different stop and turn around, things like that. You could have a stop and keep going on there too. So anyway, this is the velocity and acceleration chart. So for number 10, if that wasn't clear, it was on your assignment sheet. You need to have both in there. I want to see them both. Now, do you see the acceleration up here on my graph? You don't see it, do you? So let's talk about it. I'm going left and I'm speeding up. So let's go back over here. Oh, by the way, this was at t equals 2 seconds. Was the top spot here. But anyway, I'm speeding up. So basically, I start out here. I'm moving left, but I'm speeding up as I go into this point here. So I'm speeding up. I stop. Wait a minute. No, at 2 seconds. I don't speed up the whole time. I speed up to where? 3/4 of a second. So if I plug in 3/4 of this, can somebody do that for me? 18/4. Right. 3/4 squared is what? 9/16 times 3. I don't know. Anyway, whatever that ends up being, it's somewhere in between. Let's say it's here. So I'm speeding. So watch. Watch, I'll let you figure out the exact number, but I speed up till I hit where there's no pull, and then I slow down. So I'm speeding up, then slowing down, and then what? And then I turn around. I have right pull. I'm stopped here, but I have right pull, and then I speed up as I go up. I speed up through negative, positive infinity. Okay. So Luke, this is kind of like, Jack's on the route, he's going really fast, gonna be wide open, you just get ready to throw and he slows down. Like, are you serious? Anyway. Okay. Because he didn't think he was gonna get the ball. All right. Okay, yeah, I'm going to give you very limited current order knowledge, but did I tell you, like, back to the huddle and practice one time, like, Kurt, I was wide open, it was a scrimmage. And, he looked at me and goes, "You're always open." You ever say that to a receiver? Like, as a smart ass? No, you're like, okay. No, I'm like, Kurt, I was open on that. He didn't throw it to me. He goes, "You're always open." I said, "I know. Throw me the rock." The rock is another name for football. At least in my world. Okay, what else you want to know? Next, we're about out of time. So that's 2.5, so clean that up. 2.6, critical that you watch this video. Did you watch the videos? Are they getting any better? Like a little more lively?
Yeah.
The rock. Oh goodness, you're gonna have to ask your parents who I'm imitating there. Don't show them. So anyway, they'll make fun of it. All right. But yeah, so we got some of those. We did talk about like what an ohm is and stuff. Did I do one of those? Marginal cost, marginal revenue. That's instantaneous rate of change of cost or instantaneous rate of change of revenue. It's just a derivative. That's business calc. I teach that. Spend some time on that in business calc too, but you get that here. 2.5 you can turn in tomorrow. So turn it, tomorrow's Friday, right? Turn it in with 2.6. I do want you, how many problems are due on 2.6? Okay, so I want to see some action on WhatsApp. I mean, if you don't just, these are probably the more challenging problems. It's not like taking a derivative of t to the 5th power. Tomorrow? So, if you can, you already approved that with me, right? When do you leave? Okay. And scan it to me, yeah.
We do it on the same sheet.
Can, or you can do it separate, yeah. If there's issues with 2.6, I'll try and have it for you tomorrow. All right, Hannah, you good? Are you good?
Yeah, I'm good.
Thanks. We'll see you later.